Alright guys, in this video we're going to be trying to identify polynomial functions, and not only identify them but also list them in what we call standard form and identify two very important pieces of information that we refer to as the leading coefficient and degree. So let's just revisit what we mean by a polynomial function in the first place. And we say that polynomial functions are functions of this form that we see right here. Okay, lots of subscripts, lots of superscripts, but we basically say that the leading coefficient is this blue term up front here. So we say the coefficient that's in front, as long as this is listed with exponents in decreasing order, that's our leading coefficient. And so we'd say that if you are a polynomial, basically this whole expression right here, all of the exponents have to be whole numbers, and all of the coefficients are real numbers. And so there's one amendment that I want to make here, but basically not only are all of the exponents whole numbers, but they are non-negative whole numbers here. And so what we're going to do is make sure that I list that right here. Let's see if I can write this here. Non-negative whole numbers. And so we're going to be looking for two things here. We want non-negative whole numbers as exponents and real number coefficients. If that's the case, then we have all of these terms being added together making a polynomial function. So we say that for this function, just to note a few things here, we say that the coefficient that's in front here, coefficient is just the number that you see in front of a variable. Remember that. We say that's our leading coefficient if this is listed with its exponents in decreasing order from left to right. We also recognize that n, well, where do we see n here? Well, in red right there, n is the highest power that's on an x term or a variable there. So we say that n is the degree of our polynomial since it's the highest power. And then a subscript 0 here, or a sub 0, is the constant term. So we're always going to see this constant term back here, and we want to make sure that we remember that there. So can we recognize polynomial functions and list them in standard form with their exponents in descending order? Well, let's take a look at all these. Remember, the two things we want to check here are for real coefficients, so no imaginary coefficients, and also non-negative whole number exponents. So when we look at number 1 here, it says, well, our function of x or y equals 4x squared minus 3x plus 5x cubed minus 7. Now this looks really polynomial-ish to me, but I would say that, just to check these, we say all of our coefficients here, well, they all seem real to me. At least, here's what I don't see. I don't see any i's, and so that checks out. Also looking at my exponents, they're all positive whole number exponents here. So this does check out. It is a polynomial function. So it may be a function, but this is in particular a polynomial function. So let's write it in standard form. Well, standard form, we would list our 5x to the third in front here since it has the highest exponent, then 4x squared minus 3x minus 7. So the two things we were looking for here are degree and leading coefficient. Well, our leading coefficient here is this 5, so we're going to say leading coefficient is 5, and then our degree here is third degree, what we would call a cubic function. So looking at number 2, do we think it's a polynomial function? Well, looking at all the coefficients, are they real? Well, we don't see an I anywhere, so are they real? Yes. And checking out all of our exponents, I guess we all have whole numbers up here, but this one right here is a negative. And so we would say not a polynomial function. As much as you would want to list your exponents in decreasing order, it's not going to have a standard form because it's just not a polynomial function in the first place because of our negative exponent. Okay, so we don't have to deal with these right here. Looking at this one here, j of x, we have 8x squared minus root 3x plus 2. So we've got three terms here. Again, check your coefficients out. Are they all real numbers? And I would say that because we're taking a square root of a positive right here, well, that's definitely real. So as much as I don't maybe know the square root of 3 off the top of my head, it's still real. And looking at all of our exponents, they're all non-negative in all whole numbers here. And so we would say that yes, this is a polynomial function. And in standard form here, I suppose that it would be in the same order just because of the fact that our exponents went in decreasing order. So what's our leading coefficient? Well, up front we have an 8. And then our degree here, what's the highest exponent on any x? We say is second degree. So I'm going to list that here. Actually, I'm going to list the name. A second degree thing is something that we refer to as a quadratic. Up here we're going to write that a third degree thing is a cubic. So looking at this next one here, do we think it's a polynomial function? I'm going to have you check out your coefficients, see if they're real. Check out your exponents here. Is there anything that would make me think that this is or isn't a polynomial function? Well, I would say that one thing that I notice here is that we have a negative exponent. So we would say that this is not a polynomial, okay, not a polynomial function. It couldn't be, okay. And then looking down here, I suppose at number 8, let me see if I can move my screen here. Number 8 looks like j of x is equal to 2x cubed plus 9x squared minus 5x plus 4 over x minus 1. And this is an interesting deal here, but we have an x in the denominator. And so this is very uncharacteristic of a polynomial. And one thing that I actually do want to mention here is this. 4 over x to the positive 1 would be the same thing as 4x to the negative 1 over 1, where what I've really done here is I've taken that x to the first and moved it up here, but its exponent becomes negative. Or in other words, we get this right here. So what I'm going to do is I'm going to list something here that we'll be talking about in this class, but we say it's the negative exponent rule. And when you see a negative exponent, what we're going to do is we're going to refer to this as the move it symbol. And what I mean by move it symbol, okay, is that whenever we have a base that has an exponent that's negative, you could interpret this as being in a fraction over 1 here. But what you're going to see is whenever you move the base of something, or the base of an exponent, across the bar on a fraction, that is to say that there would be nothing but 1 left up top if I move my x downstairs, and then x would be down here. The thing is, as soon as it crosses that bar, the sign switches on my exponent. So we have a sign switch on an exponent. If we move its base across the bar on a fraction, across the bar on a fraction. And so we're going to have this come in handy in the future. Now, it's not necessary for us to rewrite it as 4x to the negative first, but I do want to write that this would be the same thing as 4x to the negative 1 because, excuse me, if you move x to the bottom of this fraction here, it would be 4 over x to the positive 1. And so we would say that this is also not a polynomial function. And one thing I suppose I want you to look out for is anytime you have an expression that has an x in it in a denominator, then it's not a polynomial function, okay? So use this to kind of help you try to identify polynomial functions, real number coefficients, whole number non-negative exponents, and then also write those in standard form and identify two things, leading coefficient and degree. Cheers.